there's no need to put carbon dioxide in our diesel feed. There's no need to put carbon monoxide. You can put a bit of oxygen, yes, definitely. You put methane, ethane, propane. Remember, these are the things that I selected up. You put propane, iButane, water is very important, it's always there. Hydrogen, yes, very important, because remember your reaction set, you are reacting thiophene with hydrogen to give hydrogen sulfide and butane, that's liquid hydrocarbon. Thiophene and all of this, you put the mole fractions of each. Maybe you put the mole fraction, you can decide to take mass fraction depending on what your data is giving you, or liquid volume flow depending on the type of data that you have, right? So after you've inputted there, you come to the conditions. You can give the stream a name here. I can double click, so I have diesel. I have my diesel feed here. Now the temperature, the document specifies that your diesel feed is entering at 77 degrees Fahrenheit and 36.4 degrees psi. So you input that, all of that here. Let me delete this. Now this is my diesel feed here. What I'll do is I'll double click on it just to show you what I've done. Okay, I've inputted the temperature, the pressure, and the mass flow. Very important. On the document you have mass flow, it's given there. You have 1.286 exponent 0.5, which gives us a molar flow of 3,536. Remember, molar flow and mass flow is very important. You give you flow rate. So for this, that's all you need to input. Is you don't need to think of everything down here. You are concerned only with composition and conditions. That's all. You're not concerned with properties. It's automatic. It calculates composition and condition. Composition is where you put the mass fraction. Conditions is where you input your temperature, your pressure, and your mass flow, depending on which one you have. So now, after putting remember, we always have three parameters which we have to vary: temperature, pressure, and volume with flow rate. These are the three key things when you're simulating. And okay, remember to plus your output, that the desired output that you want. So the first thing is I'll put a pump. Remember, this diesel here is coming in with liquid, so I can put a pump. So when I input the pump, I'll define my inlet, what is entering the pump here. This diesel here enters the pump, so the inlet here is diesel feed. This diesel feed that I've included. Now remember, the pump needs an energy stream, so I come back to my model palette here. I don't know why that is not working. Wait, let me take it from here. So yes, I drag this energy stream and I place it here. This is the only example for which I will show. You take the energy stream and you place it here, then you double click on your pump, the energy, you select it. So for our own selection is Cure 100, right? So I don't need to use this Cure 108 again, so I delete it. You are not touching anything. You don't double click on it. Aspen will automatically calculate the energy that is needed for that pump. So my outlet is going to be pump diesel. Why? I'm trying to increase the pressure of the diesel. So the outlet, you label it pump diesel, you take enter, right? Then I come to parameters. You're looking at the connection and parameter. So here I'll come and I'll input my delta P. Your delta P value is just the pressure difference between what is entering and what is going out. So if you take the pressure at this point, like here, you see the pumped pressure here is 1559 psi, right? Yes, 1559, and the input, the feed pressure here is 36.45 psi. Delta P, change in pressure, you simply take this minus this. So if you want to increase this, simply means this value should be high, right? So that if you take this minus this, it will be bigger. You have 159 It's easy. Delta P is just change in pressure. So when I put my delta P, now remember we have gases too, so you enable multi-phase pump. If you don't enable multi-phase pump, you are saying that your pump will only pump liquid. But when you enable this, it's going to use a correlation that will avoid you having cavitations in your pump. You don't want to destroy your pump, right? So a pump that with enabled multi-phase pump mode, which uses a correlation, helps you reduce the risk of destroying your pump. Remember, pump cavitation is a problem in the industry. So now we need hydrogen. So if I look at this diesel feed here and I go to composition, you notice here that at the level of hydrogen I've not put any value. It's 0. It simply means that the diesel feed is coming without hydrogen and our reaction needs hydrogen. So I will not put anything. Oxygen, carbon dioxide, CO2 and thiophene, they are empty. I can still input values for thiophene here at the level of this feed here. I can still put values for thiophene depending on the quantity that you have. I think I should normally put something there, but it's okay. Nevertheless, the simulation will still be the same. So I take my makeup hydrogen here. I'll come to composition and I'll put 1 at the level of hydrogen, or depending on the quantity of hydrogen I want to put. For mass fraction, I'll just simply put 1 and I close it. That's all. I don't need to put anything again. The conditions, okay, you put your temperature, your pressure. The pressure should be consistent with this, with the pressure coming from the pump, so it should be consistent. And then I send it to a mixer. I want to combine my diesel and my hydrogen with the thiophene and everything before we separate it. So I send it out to my mixer. So in order to select a mixer, remember, you go to the model palette, you take a mixer, or you search it. If it's not available, take mixer. This mixer comes in, you drag it and you drop. Simple, you drag and drop. So I'll double click now on that mixer. Now remember, we are looking at connection and parameter. That's all. With the rating, you can maybe say, okay, it's elevated from the ground or something, but you're looking at connection and parameter. Connection and parameter, that's all. You're linking. What are you trying to mix? You're trying to mix diesel and you're trying to make up hydrogen. So here at the level of inlet, that's what is coming in. Make up hydrogen here, pumped diesel, this, and then the outlet, I'll specify that is the mixed feed, like I've specified here, mixed feed. That's all. It calculates everything for you. You see the change in pressure, right? The change in temperature and pressure is still the same. Then temperature has changed, 404 here Fahrenheit, 2160, and then we have 2011 Fahrenheit here. Now our reactor, you cannot send in cold feed into the reactor. For one of the reaction conditions is high temperatures of about 3361 Fahrenheit for easier conversion. So I will add a heater, what I call heater. So I'll just come here, look for heater. You can use a fired heater, but the fired heater is old. I think it's the one that is in Sonara's document. Yes, here. You can use a fired heater, but I prefer this heater. So I drag and drop here. Remember, it requires energy. Same thing for energy stream as I explained here. Double click on it. You just have to put the inlet. Your mixed feed enters your heater, and the energy, like I explained. Outlet, I'll label it heated mixed feed. Then I come to parameters. I'll monitor. What are we monitoring when we're heating? Temperature, right? You don't need to touch anything here in pressure. Just delta T, change in temperature. Change in temperature is what is entering. Temperature of what is entering minus what is going out. Change, that's the change. It's the same as delta P.